Bismillahirrahmanirrahim. Yesterday we saw how to transform ER diagram into relations, and we covered the first three of those, like how to transform or map regular entities into relations, how to map weak entities, and binary relationships. Today we will cover the last four, which are how to map associative entities, unary relationships, n-ary relationships, and supertype subtype relationships. So let's start with the mapping of associative entities. Now, to map an associative entity, we first of all we let's start with this example. This is an associative relationship in which we have an associative entity order line that and the associated relation and entities are order and product. So when we have to map an associative entity or an associative or a man-to-man relationship, we will create one relation for each of these entities. So we will create a relation for order, just like we create a relation for a regular entity in step 1. We create a relation for product, and we create a relation for order line. Now, while creating a relation for order line, we include the primary keys of the related relations, which are order and product, in the order line. So here is the relation order, which has order ID and order date. Here is the relation product with product ID and the other non-key attributes, and here is the associative entity associated relation by the name order line. And in this relationship we have included the primary keys of the related relation, which is order ID and product ID, as foreign keys, and we have made this these two foreign keys as the primary key of this associated relation. Now there are basically there are two cases while creating a primary key. First, in which we don't assign a new identifier, and this case is called identifier not assigned. And this is the case we have just discussed, that we don't introduce our own primary key here. Instead, we make the these two foreign keys, which are actually primary keys of the related relation, as a composite key of the associated relation. The second case is we assign our own identifier to the associated relation, and we do this in further two cases. In the first case, when there is a natural identifier for the associative entity, and we can see that while making an associative entity in the ER diagram, we come up with an attribute that is a natural identifier for that entity. In that case, we make that identifier a primary key in our associated relation. Here is an example. We have these two relations and plus an associative. We have these two entities, customer and vendor, and an associative entity between them by the name shipment. And this entity has a natural identifier, which is shipment ID. So when we will map these into relations, we will map this as a regular entity, we will map this as a regular entity, and while mapping this, we will make shipment ID our primary key, and these IDs, which are customer ID and vendor ID of the related relation, will be included in the associative relation as a foreign key. So here customer ID and vendor ID are foreign keys, and shipment ID is the primary key of shipment relation. We follow this rule if these this is the first case in which the associated relation has its own natural identifier. But let's say if it doesn't have its own natural identifier, and these two attributes, uh, which are the primary keys of the related relation, don't uniquely identify a record in the associated relation, then in that case as well we create a surrogate primary key, or our own introduced primary key in the associated relation. Let's see, do we have an example of it? No, we don't have an example here, but uh, let's say if shipment ID was not an attribute of shipment, but customer ID and vendor ID don't uniquely identify a shipment record in a shipment relation. In that case, we will also introduce our own unique identifier or a primary key in the associated relation, and normally that primary key becomes uh, because it is not a natural primary key. So a general practice is that when that primary key we make that primary key an integer field or an integer attribute, and we assign it numbers in ascending order, like in the first record we assign it the value 1, in the second record we assign it the value 2, and so on. When we will cover database in the next course, uh, such primary keys are called auto increment fields. So in short, very quickly, there are two broad cases. In the first case, we don't assign an identifier ourselves, but instead we make the primary key of the related relation as a composite key of the associated relation. And in the second case, we assign an identifier to the associative relation. Now it has further two cases. In the first case, there is a natural identifier available in the anti-relationship diagram. So we make that attribute primary key in the associative relation. And in the second case, where we don't have a natural identifier, and the composite key, which consists of two foreign keys of the associated relation, does not uniquely identify a row in the associative relation. In that case, we introduce a surrogate primary key. And I have just given you an example of it, that in case if shipment ID was not a natural identifier, then we introduce it ourselves, because customer ID and vendor ID does not uniquely identify a row in the shipment. Reason: a customer a vendor can send a shipment to a customer many times. Like a customer has ordered a shipment and a vendor has sent the shipment. Yes, today, after few days, the customer again orders a shipment and the vendor sends the shipment. So again there will be same customer ID and same vendor ID, because one customer can receive shipment from the same vendor many times during its business life. So it means that these two attributes cannot uniquely identify or cannot be made a primary key in the shipment relation. So in such a case, if there had not been a shipment ID, a natural primary key, even then we would introduce a shipment ID as a surrogate primary key and made it an integer field with an auto increment values in it. So this is how we map an associative entity into a relation. Now the next is how to map unary relation. We know that in case of unary relation, the relationship is between the same entity, like relationship of a student with a student using relationship of a CR with a student is a unary relation. A CR is also a student. Similarly, relationship of faculty with head of department, relationship of employee with manager, these are all examples of unary relationships. So let's take this example. an employee and a manager, and an employee manages many employees. If an employee is a manager, he manages many employees, and many employees are managed by an employee or by a manager. So here the relationship is manages or managed by, and the relationship is one to many. So it is basically unary one to many relationship. In this case, we map this entity into a relation using the rules of mapping a regular entity. But we do one additional step, and that is we add the foreign key of we make this employee ID. We create a foreign key of this employee ID and add that foreign key in the same relation. This is important. The foreign key is added in the same relation. Otherwise, the foreign key is always in another relation. So this manager ID is a foreign key that I have added to create a unary one-to-many relationship, and this manager ID has the same domain as the employee ID. When we say same domain, it means the data type of manager ID and employee ID are same. Their field size or length of their data type. Let's say if it is integer 10 digits, it should also be integer 10 digits. If it is a character field of 5 characters, it should also be a character field of 5 digits, 5 characters. And the range of values that of these two fields should also be same. So let's say if employee IDs can be from 100 to 1000, the manager ID, the possible values for manager ID will also be from 100 to 1000. So in short, these two fields are identical, they are same. So we make this a foreign key of the primary key, and we add this foreign key in the same relation. Such a foreign key is called recursive foreign key. So in short, we add a recursive foreign key in the same relation. So this is how we create, translate or transform or map a unary one-to-many relationship. Now let's see the case of unary many-to-many relationship. In case of unary many-to-many relationship, so this is first example. This is case of an item that is made up of many other items. Like we create an item with different parts, and all those parts are also called items. So an item contains many items because it is made up of many items, and one part is included in the manufacture of many items. So that is why the relationship between item and item is many to many, and the attribute of this relationship is quantity. So we can say that an item contains 5 parts of a specific type, or 5 parts of one part of a specific type is used in the construction of many different items. So while mapping, the rules for mapping such an unary many-to-many relationship is, first of all, you map this entity as a regular entity. So we have one relation, the name item, which has the same attributes as the attributes of this entity, and we create an associative entity, let's say component or part. We include 2 attributes. One is the same primary key of the including related relation, which is item, and we create a foreign key of this same item number in the relation, which is component, and we add the non-key attribute, which is the attribute of actually this relationship, as a non-key attribute of this associative entity. So in short, we create an associative entity, we add the non-key attribute, which is the attribute of this many-to-many relationship, as a non-key attribute of this associative entity, and we include this item, the primary key of our entity or this relation, two times in our associative entity, and both these are actually foreign keys. This is also a foreign key of item number, and this is also a foreign key of item number. This is how we map a unary man-to-many relationship into uh, into relation diagram. Although they have not given any example here. Now let's say let's take a very simple example. Suppose we have an item number 1. Item description is car, and it has any unit cost. Now a car is made up of many parts. Now let's say again item number 1, which is car, has 4 tires. Let me give you an example. We have an item relation, we have a component relation with the respective attributes. Now let's say one item is suppose Corolla, tire, engine, weights, and premium, and these are the component record. Corolla has 4 tires because component 2 is tire, and it has 1 engine because component number 3 is engine. Similarly, weights has 4 tires and 1 engine. I have just taken a very simple example. Now against each item, or in each item, we have many components. So in Corolla we have 2 components, and one component, which is, let's say, tire, is being used in many items. Component 2 is being used in item number 1, component 2 is being used in item number 4, which is weights, and similarly in 5, which is premium. So this is how there is a man-to-many relationship, and this is how we have translated an unary man-to-many relationship in an ER diagram into a relation diagram by separating that single entity into 2 relations. Next is how we map n-ary relationship. This technique is similar to how we mapped this associative entity, in which we have man-to-many relationship between 2 entities. This one. So the rule is same. Let's quickly go through the example. Now this is a case of n-ary relationship. Now there are 3 entities which are related to each other using a man-to-many relationship, and the entities are patient, physician, and treatment, and their associative entity is patient treatment. So first of all, we will create one relation for each one of these entities. So there is a relation for patient, one for physician, one for treatment, and one for patient treatment. So patient, physician, treatment, and patient treatment. Now in case of patient treatment, we will map it using the same rules in which we map the associative entity. We will include the primary keys of the related relations, which are patient, physician, and treatment, as foreign key in the patient treatment. So we have patient ID, physician ID, and treatment code as foreign keys in the patient treatment. Now first of all, we will see that whether these 3 foreign keys can make up a primary key in the associative relation. Now we see that they don't, because a patient can go to a physician, get a similar treatment many times. So now the patient treatment has 3 non-key attributes, which are treatment date, treatment time, and treatment results. If we include treatment date and treatment time, these 5 attributes uniquely identify a treatment record, because a patient can go to a physician, same physician, for same treatment code many times, but obviously not on the same date and same time again and again. Even the patient can go to same date twice, but not at the same time. So if we include the treatment date and treatment time along with these three attributes, then these five attributes become a primary key or a composite key. So it means that we don't need a separate surrogate primary key in this table. So the rule is that first of all you include the primary keys of related relations as foreign key in the associative relation. Then you try to figure out that whether these foreign keys or these foreign keys along with uh, the any combination of non-key attributes make up uniquely identifies a record in the associative entity. If it does so, you make all those fields or attributes primary key or a composite key in the associated relation. But if they don't, then you include your own surrogate primary key in the associated relation and make that attribute a primary key of the associative relation. So this is how we create we map n-ary many-to-many relation into a relationship diagram, a relation diagram. Last one is the mapping of supertype and subtype relation. Now it's also fairly simple. This is a ER diagram of a supertype subtype relation. First of all, we will create one relation for each of these supertypes and subtypes. So there will be a relation for employee, for hourly employee, salaried employee, and consultant. Once we are done with that, we will include this primary key, which is primary key of the supertype, as primary key in all these subtypes relations. So we will include employee number as primary key in the hourly employee relation, and also in the consultant relation, and in the salaried employee relation. We have just changed the name. We have changed this name to hourly or edge employee number, but they are actually the same because we use this primary key as a primary key of each of our subtypes. So first step is you create these relations with their respective attributes. Then you include the primary key of your supertype as primary key in your subtype relations. And the last thing is you add a subtype discriminator attribute field in your supertype relation. So this employee type is a subtype discriminator field. So this is how we map a supertype subtype relation, supertype subtype ER diagram into supertype subtype relations. Okay, here is a summary. You should keep reading this summary again and again periodically, so that you have this mapping on your tips, because this is very important. Once you have your ER diagram, the next step is to map that ER diagram into relation diagram. So these are all the rules that we have covered till now. In the next class we will start normalization, and probably in the coming 2 lectures we will cover this normalization, which is our last topic.